Hello, this is Team 11, and we are here with our final presentation for the snowboard binding analysis and redesign. As you can recall from our interim report, snowboard binding is a mechanism that binds one's feet to a snowboard. Um, there's two straps that will lock the user's feet into the board. There's a footbed that will allow for secure foot holding and a little bit of movement. The high back allows for the user to lean and really lean their power into the board and transmit power in the appropriate way and direction that they are aiming to do so. We note that our snowboard binding often comes in sets of two, as you will need two for one snowboard. Um, Market information suggests that over 600,000 snowboards are purchased in a year. And then with our snowboard binding, we have two separate target markets. The first are manufacturers that will buy many snowboard bindings in bulk and then use this to manufacture a final snowboard and sell to customers. Our secondary customer will be individual snowboard owners who may not buy as highly in bulk and may require more customization or maybe more amateur and want a little bit more modularity in their feel. We know our original design with an exploded cat. We also have a fast diagram with two primary functive branches. Here's a quick charts relating our similarities and differences among customer groups, and then some of the platforms and modules that will apply to these different customer groups. We have simplified our BOM down into a chart that analyzes the total assembly time and then the component number. Here we've taken the quad chart and are analyzing it for our manual assembly redesign. We note the high back and the clip mechanism are some of the high functional importance, and we are seeking to simplify this and maybe save some costs. We also note the toe buckle, ankle buckle are, while they are low cost and high importance, we do believe there's some option to save some time and some costs by redesigning these. We've laid out the individual components that we'll be modifying and noted there's some of their functions in the FCMM table. For the modular design, as you can see from the prior table, the buckles serve the same purpose, though they have different shapes given where they serve on the product. We know that there's a possibility to replace the buckle on the toe strap and use the same design that's already being used for the ankle buckle. This ankle buckle has been applied to the toe strap for markets that may not necessarily require like unique buckles, and this will serve the same exact purpose and allows for more modularity in the design. We've also taken a platform design that will remain the same for either target market. This involves the high back and the clip base along with the clip mechanism, and we are seeking to condense the parts and make this more feasible for all consumers. After redesign has been applied, we've completely eliminated the clip mechanism and we've simplified the attachment of the clip base to the high back. This allows us to serve the same exact function with this sub-assembly type setup, but we've accomplished so much more and saved more money in the process. After performing manual redesign, we've moved to redesign for automated assembly. This focuses on the toe strap sub-assembly of the boot. We can also see that the toe cap and toe strap serve the same exact function, while the strap just provides a little bit of comfort, so we're attempting to condense the total number of parts. With the automated redesign for the sub-assembly, we were able to join both parts into one and serve the same exact function. We do this by joining them in the manufacturing, and then we allow mold and fasteners, and we also have the option to replace these with a torsional ratcheting strategy, such as in the ankle strap. Continuing on, we would like to design for manufacturing with the toe strap and the toe cap. We believe we can condense these in one, and then we update to show what the matrix would look like with just the toe strap component. With this design for manufacturing, we need to determine a process You can see we've considered many different processes for this plastic material. Uh, we have two possible candidates, but we see that injection molding is the best option to move forward with. We also have another material and part that we've chosen for manufacturing changes. This involves the footbed adjustment, which has a high functional importance despite only serving one function. We believe that if we use this for machining instead, we would be able to serve a greater purpose. While we've chosen machining, we've also considered many other uh, processes, and there are some candidates that survive, but we still believe machining would be the best option. We then move forward to establishing a product service system where we can have greater benefits beyond just redesigning the parts. First, we have an environmental focus where we use biodegradable materials or recycled plastics in manufacturing. This can be used for parts that don't need necessarily high durability or reliability. We also can establish a take-back program where low-functioning parts can be taken back for incentives, and in return, we will be able to repurpose these parts. Further, you can enhance customer satisfaction by enabling personalization of some of the modular parts, and also enhancing user friendliness by making some of the adjustments much more easy for customers to use, and thus enhancing the market that you can reach to. In conclusion, we've performed many analysis and redesign of parts of the snowboard binding. We believe that this will reduce costs, reduce assembly time, and enhance customer satisfaction of the part overall.